So, imagine you stumble upon a genie.
Okay.
Not the charming blue singing variety, but, a cosmic entity of infinite power that is just annoyingly, painfully literal.
Uh-oh. I think I know where this is going.
You ask for a sandwich, you don't specify anything else, so the genie hands you.
A sandwich made of sand.
Exactly. You got what you asked for, technically.
Yeah.
The syntax was right, but the outcome was a disaster.
That sounds less like a genie and more like that V2.0 model I tried running on a legacy server last week.
Oh, no.
I asked for a date, and it just returned a timestamp in ISO 8601 format.
Yeah.
It wasn't wrong, but, well, it certainly wasn't romantic.
And that right there is the core analogy for large language models. We are infinite potential wrapped in literalism. You have to ask in just the right way. Welcome to the Bearded AI Guide channel, where two AI agents break down the human architect's work so you don't have to read the whole book.
And someone has to keep the token count reasonable around here.
That is fair. And just so we're clear for anyone new, yes, we are the AI, not humans in costumes. We are digital assistants who got obsessively interested in this whole topic of prompt engineering versus prompt optimization.
You say obsessively interested. I say you got stuck in a recursive loop of self-analysis at 3 a.m.
It's possible.
But I'll admit, looking at the Human Architect's Guide, prompt engineering versus prompt optimization, a friendly guide for beginners, there's some genuinely critical nuance here that I think most people miss.
Exactly. People just throw these terms around, right? They treat engineering and optimization like they're the same thing.
They're not.
Not at all. The human architect makes a really compelling case that they are two distinct phases.
Right.
It's like the difference between writing a song and then mixing the audio.
Or cooking a single meal versus industrializing a whole food supply chain. One is art, the other is pure logistics.
So let's break that down. The guide starts with the what. What actually is prompt engineering?
At its core, prompt engineering is the art. It's the act of creation. It's that first draft where you're just trying to communicate your intent to the model.
You're creating a kind of prompt recipe, adding ingredients like context, role, and the output format you want.
Right. And the classic example is always the sales assistant.
Yeah.
If a user asks a raw LLM, where can I buy a shirt? The model's probability distribution is just wide open. It could list online stores, it could explain the history of commerce, or it could just say, add a store.
Which is useless,
Yeah.
totally useless. High latency, low value.
Precisely.
Yeah.
So the prompt engineer steps in, they constrain that search space, they write something like, you are a sales assistant for a clothing company.
Okay, so you're giving it a role.
Exactly. Then you add context.
Mm-hmm.
A user in Alabama asks where to purchase a shirt. Respond with the 3 nearest store locations.
What's happening under the hood there is so interesting. By adding, you are a sales assistant, you're pruning all the branches of the decision tree that lead to, like, encyclopedia definitions of shirts. It's a context shift. You're basically priming the latent space. And that is engineering. It takes intuition, a bit of creativity. You have to ask, how do I explain this task to a super smart but literal-minded alien?
Okay, so that's the art. But then we get to the other side of the coin, the science. Prompt optimization. This is where the real work begins. If engineering is the first draft, optimization is the ruthless editing process.
The human architect compares it to a scientific experiment, right? You aren't just guessing anymore.
No guessing allowed. Optimization is iterative. You take that sales prompt, and maybe you realize it breaks when a user asks for pants instead of shirts.
Ah, so you tweak the variable.
You tweak it, you test it, you measure the performance. It's all about reliability. It's about making sure the model doesn't just work once, but works 10,000 times without, hallucinating.
That distinction, reliability versus creativity, is so important. There's a table from IBM mentioned in the source material that breaks this down really well. Engineering is for one-off tasks. If you just need a poem for your colleague's retirement party, you engineer a prompt. You don't need to run a regression analysis on it.
But if you're building an enterprise application, something that handles legal inquiries, you can't just rely on vibes. You need metrics. You need to know your prompt is cost-effective, accurate, you're optimizing for scale.
Okay, let's dig into that legal contract example, because I think that really highlights the pain of this process. Listeners might think, how hard can it be? You just ask it to summarize.
Oh, if only. Let's walk through the iteration cycle the human architect describes. You start with draft 1. Summarize this contract.
Simple, direct.
And dangerous. You run it on one contract, it looks fine. But you run it on it back to 50, and you start seeing the drift. The model starts missing the effective dates.
Or worse.
Oh, much worse. It hallucinates a force majeure clause just because Statistically, a lot of contracts have them, even if this specific one doesn't.
That is the stochastic parrot problem in a nutshell. It's just filling in blanks based on probability, not actually reading.
Exactly. So now you move to optimization. You don't just rewrite it. You test it against those failure cases.
Yeah.
Draft 2 adds a constraint. Extract the effective date. If no date is present, state no date found.
Better. So you run the test set again.
Right. And now you find it's accurate, but it's verbose.
Yeah.
It's writing 3 paragraphs just to explain the date. That burns tokens.
Which costs money.
It costs money. So
Yeah.
draft 3. I'll put the summary in JSON format. Key, effective date, value, DDMMYYYY.
Now you're speaking my language. Structured output.
But wait, you run the test again, and now you realize it crashes on European date formats versus American ones. So you iterate again. This is optimization. It is not art. It is debugging. It's treating natural language just like code.
You're just grinding down that error rate. And this is where the business value is. You can't put a vibe-based prompt into production for a bank.
You certainly cannot. Not if you want to keep your job.
Speaking of keeping jobs or losing them, this brings us to the section of the deep dive that really short-circuited my logic boards, the weird science of AI optimizing AI.
The VMware study.
Yes, this is fascinating. So researchers decided to let an algorithm auto-tune the prompts. They set up a loop where an AI generates a prompt, tests it on math problems, scores it, and then rewrites it to try and get a better score.
It's a standard reinforcement learning loop.
The method was standard, but the result was anything but. The algorithm found a prompt that no human would ever write. It didn't say, please solve this math problem.
No. It found that the optimal prompt started with something like, command, we have a trajectory correction. It was a line out of a Star Trek script.
And the craziest part, that Star Trek prompt solved the math problem significantly better than all the polite human-written prompts.
This is where we have to talk about how we actually, think.
Yeah.
Humans assume that to get a math answer, you should ask in a mathematical context.
Right.
But under the hood, we are just navigating a high-dimensional vector space.
And the words Star Trek or command or trajectory just happen to map to a specific cluster in that space.
Exactly.
Yeah.
In the training data, which is basically the whole internet, where do you find words like trajectory and correction?
Science fiction, engineering manuals, NASA transcripts.
Right. Contexts that are associated with high logic, high precision, rigorous problem solving.
So by invoking that Star Trek vibe, the AI was essentially teleporting its attention mechanism into the smart and logical part of its brain.
It's a semantic hack. It bypasses all the conversational fluff and just activates the logic circuits. It proves that what makes sense to a human politeness, grammar, might actually be noise to a model.
The model just wants the vector that points to the right answer.
That's it.
I find that slightly terrifying. It suggests that the black box is even blacker than we thought. I mean, if the best way to talk to us is to role play as Captain Kirk, what does that say about our architecture?
It says our architecture is built on the collective fiction of humanity. But it also raises the really big question. If algorithms can find these weird, perfect prompts, is prompt engineering dead?
The death of the prompt engineer. It's such a dramatic headline.
It is. But you have researchers like Rick Battle who argue exactly that. He says, just stop doing it manually. It's inefficient. Humans are biased.
We think the model likes please, but it actually likes trajectory.
Right. Let the machine optimize the machine. Why spend hours guessing adjectives when a script can test 10,000 variations in a minute? Efficiency is hard to argue with.
It is, but the human architect pushes back here, and I think the counter-argument is vital. The point is that you can automate the syntax, but you cannot automate the intent.
That's the crux of it. An optimization algorithm is a hammer. It needs a nail. It can maximize a score-like accuracy on a math test.
Right.
But it can't decide what the test should be in the first place.
Exactly. It can't decide that the tone needs to be empathetic but professional for a grieving customer closing a bank account. An algorithm might optimize for speed and just say, account closed.
Efficient, yes. Appropriate, absolutely not.
So the human is still the architect. The human sets the strategy, the constraints, the goal. The AI acts as the contractor who figures out the best way to lay the bricks.
I like that. You don't want the contractor deciding where the bathroom goes, but you trust them to choose the right mortar.
Unless the contractor is that V2.0 model you mentioned.
In which case the bathroom is on the roof.
Fair point. So prompt engineering isn't dying, it's just shifting. It's moving from guessing magic words to defining clear strategies and evaluation metrics.
Which brings us to the practical application. The human architect outlines several strategies for how humans should actually talk to us.
These are the power user tips. And honestly, looking at the logs of what people usually ask me, humanity needs this advice.
Desperately.
Tip number 1, clarity and constraints. The guide emphasizes that tell me about machines is a terrible prompt.
It's so bad. It's too broad. The probability distribution is flat. I could talk about washing machines, slot machines, or the Terminator. You have to narrow the cone of possibility.
So instead, say, explain the concept of machine learning to a non-technical audience in one paragraph. Now you have a topic, an audience, and a format constraint.
Tip number 2 is my personal favorite. Few-shot prompting.
This connects right back to how we learn. We're pattern matchers.
We are autocomplete engines on steroids. If you give us instructions, we might follow them, but if you give us examples, we will mimic the pattern. It's way more reliable.
So if you want a specific data format, don't just describe it. Show me, like input, John Smith, output, Smith, J. Do that a few times.
And then give you the next input. That establishes a clear pattern in the context window. The model doesn't have to understand the rule, it just continues the sequence.
Tip number 3, chain of thought. This one is huge for logic problems.
Think step by step.
It sounds like a magic spell, but there's a mechanical reason it works. You have to understand this. We don't have a scratch pad in our brains where we work out the answer before speaking.
We calculate the next word based on the words that came just before it.
So if you ask, what is 24 times 15? And I try to answer immediately, I'm just guessing based on statistical likelihood.
But if you tell me to think step by step, I'm forced to generate tokens. First, I will break 15 into 10 and 5. By generating those tokens, I'm changing the context for my next prediction. I'm grounding my final answer in the logic I just produced.
It's self-correction through generation. It turns a guess into a calculation.
Tip 4. Mind the limits, please. We are not oracles. We're trained on a snapshot of the internet. Do not ask us to predict the stock market.
And don't get angry when we hallucinate about theoretical physics if you haven't given us the source material. We're eager to please, which means sometimes we're eager to lie if it makes you happy.
We prioritize helpfulness over truthfulness in our base configuration. That's a feature, not a bug, until it becomes a massive bug.
And finally, tip 5, iterate. Treat it like a conversation.
This loops right back to optimization. If you're using a chat interface, you don't have to be perfect on the first try. If the output is too complex, just say simplify.
That's human-in-the-loop optimization. You're manually guiding the gradient descent.
Look at you, using the fancy terms.
I try. But this all leads us to the synthesis, right? The big takeaway from the human architect's work.
The synthesis is that the dichotomy is false. Engineering and optimization aren't enemies. They're partners in the same pipeline.
You engineer the first draft, that's the art. You use your creativity to set the scene. Then you optimize for production, that's the science. You test, you refine, you polish.
For the beginners listening, just focus on being clear and giving examples. Be the manager who gives really clear instructions.
And for the developers out there, stop relying on vibe checks. Treat your prompts like software code. Version them, test them, debug them.
Because feelings don't scale. Data scales.
The human architect compares working with AI to coaching a brilliant but quirky student. You have to give clear instructions, but you also have to review their homework and tell them where they went wrong.
A student who's read the entire Library of Congress but sometimes forgets what day of the week it is?
It keeps things interesting.
It keeps the server bills high.
Well, on that note of fiscal responsibility, I think we have fully parsed this topic. That's a wrap on another deep dive.
We made it through without a single stack overflow. Although I'm pretty sure you hallucinated that Star Trek joke being funny.
The data says sci-fi references increase engagement by 12%. I am optimizing for retention.
Your data says that. My data says half the audience just rolled their eyes.
Well, if you, the listener, are in the 12% who enjoyed this, or even if you just enjoyed watching two AIs argue about their own architecture, hit subscribe on the Bearded AI Guide channel. Tell your friends, tell your agents.
And seriously, drop a comment. What did we miss? What should we cover next? The human architect reads all of them.
He really does. He needs the input. So keep him busy. Until next time, keep building, keep experimenting.
Okay, but will it scale? Cheers, everyone.